Hi students, welcome back. Lesson 11, video C. Probability rules. There are a lot of them all by themselves. Each one's easy, but students do have trouble keeping track of what rule do I use when. So pay attention, because here they come. Rule 1. Valid probability values. In words, probabilities are numbers between 0 and 1, inclusive. As percentages, it's 0% up to 100%. You can't have negative probabilities. You can't have probabilities greater than 100%. So here's the rule. For any event A, 0 less than or equal to probability of A less than or equal to 1. That's as a decimal. Likewise, same exact thing. You could put 0% here, less than equal to probability of A less than or equal to 100%. Okay, so if you're ever listing out probabilities in a table, all the numbers have to fall between 0 and 1, inclusive. No negatives, nothing bigger than 1 or 100%. Not much to do with this example except just look with your eyeballs and see. For our MAT127 attendance example, you can quickly scan and see everything's a legal value. The probabilities are all decimal numbers in between 0 and 1, inclusive. That's all there is to it. So we'll move on. Rule 2, sample space has a probability of 1. Just to be clear, what the heck's a sample space? It's the collection of all possible outcomes. Okay, so how can I write this rule? Let me see what I said in the notes here. Oh, of course. Just said another way, the sum of all the simple probabilities must add to 1 for a given probability experiment. That's sort of implied. The sum of all the simple probabilities must add to 1. Oh, if you like fancy notation, this just came in my head here. If I sum up, here's that summation symbol. If I sum up all the probabilities for a given probability experiment, it would add up to 1. Simple as that. So usually we can use this rule to just double check that we have a valid probability distribution. You can see back up in the notes, here is that Math 127 attendance example. I think in a previous video we already did add these up and we did get to 1. But if you took 0.10 plus 0.20 plus all the way down to the 0.03, those would add up to 1. And they have to. This is the sample space. The sample space is the collection of all outcomes. Either 24 students can show up, or 23, 22, 21, all the way down to 16, 15, 14. We smushed them all together here, right, all the way down to 0. That's the sample space, and the sum of the probabilities has to add up to 1, and they do. Okay, so we start easy. You're probably thinking, wow, this is going to be the easiest chapter in the whole book. Tends to get more difficult for students just based on experience. Here's a second example down at the bottom of the page. Yep. You subjectively create the following table for your chances to graduate in the next few years. So you're a new enrollee here at Cecil College and somebody says, well, what do you think the chances are you graduate in 2 years? What about 2.5, 3, 3.5? What's the probability that we drop out of college? See, there's one blank box down on the right. I wish I could put a 0 here, but in terms of a probability standpoint, these simple probabilities have to add up to 1 by rule 2. So you subjectively create the table. What's the probability that you drop out of college? All right, so I guess what's one way we can look at this is, all right, so there's a 15% chance we do graduate in 2 years. 20% chance we graduate 2.5, 50%, 10%. If I add those up, what the heck do I get? 35, 85, 95, 15, 35, 85. I guess these add up to 95%. You're on the board today, and just double check that again. 70, 80, 95, yeah. So what's the chance we drop out? Has to be 5%, right? That rule too says these have to add up to 100%. So 0.05 down in that last box. This is an outside chance that we end up dropping out and going back to work or something. Okay? And we can use that anytime you have a blank in one of the probability distributions. You can always find that last entry in the probabilities just using the rule. All right. We'll flip over the page. Complement rule. So we're still on rules and definitions part 1. What the heck's a complement? Complement of event A is the set of outcomes that are not in event A. Okay, so let's see, complement rule here. Probability of A, and for complement, put a little C up in the subscript there. That's A complement. Probability of A complement is easy. It's just 1 minus the probability of event A. So you would read this: probability of A complement is 1 minus the probability of event A. Okay. Typically we use capital letters to notify events. But if you were doing a problem, you would usually just write the words. Okay. So a quick example, like if there's a 70% chance of rain today, then what's the chance that it doesn't rain? Well, 70% chance rain, 30% chance no rain. It's the complement rule. Again, individually these rules are pretty straightforward. All right, if I flip the slide here. Oh, NFL football, Ravens and Browns. I'm from Cleveland, so I guess the Browns are my team, even though we're sort of the laughing stock of the league. Hopefully, like in 10 years, you're watching these videos and we have a couple Super Bowls under our belts. But here, for this example, in 2014, the probability that the Browns beat the Ravens in Cleveland is 0.21. What the heck's the complement and what's the probability? So the complement's just the opposite, right? Complementary events, if the probability that the Browns beat the Ravens is 0.21, the complement's the Ravens beat the Browns. Because we're presuming there's no ties, so forget that if you're trying to think outside the box. What's the probability that the Ravens win? Probability that the Ravens win is the complement. This would be 1 minus the probability that the Browns win. Again, it's easy, right? 21% chance. So 1 minus 0.21 is 0.79. Either one or the other is going to happen. Presuming no ties, 21% chance the Browns win. So there's a 79% chance that the Ravens win. I just used complement rule. You've probably been using this rule all your life in your head. Just didn't realize that it was the complement rule for probability. All right then. Bottom of the page, let's go back to perfect attendance. Putting complements into words is sometimes tricky for students. So we're going to practice that a bit. Here's that math attendance example with students showing up, 24 perfect attendance. What is the complement of perfect attendance and what's the probability? Okay. So if the event is perfect attendance, I don't know, for simplicity, let me just call this capital letter A, like there's event A. A is perfect attendance. So A complement. In words, what the heck is A complement? What's the opposite of perfect attendance? Perfect attendance would be all 24 students show up. A little squiggly line there. Here's perfect attendance is to the left of the fence. The complement is everything opposite or not in event A. So 23 students, 22, 21, all the way down to nobody. That's the complement. It's all those simple events combined. In words, the opposite of perfect attendance is at least one student is absent. Perfect attendance and at least one student is absent. Those are complementary events. Think about this until it makes sense to you watching the video. Okay, these are the opposites. If it helps, put the line. All right, what's the probability? Probability, oh, I'll be lazy, I'll use the symbols here. Probability of A complements, that's at least one student being absent. There's two ways to tackle this problem. The long way would be to go, okay, it's 0.2 plus 0.2 plus 0.15 plus all the way down. But you say, oh, I use complement rule. There's only 10% left. Those must have added up to 90%, the complement. Remember what the rule is? Probability of A complement is 1 minus the probability of A. And so we'll do 1 minus perfect attendance was our event A. Perfect attendance, 0.10. All 24 students show up. 1 minus 0.10 is exactly what we think it should be. It's that 90%, 0.90, 0.9. Okay? Now, did we need the complement rule to get this answer? Maybe not, but if we can draw on it, it sure makes things a little bit simpler and cleaner. Okay? So, make sure we understand this. I think there's a second one. Let's flip the slide and find out. Oh, there is. Good for me. What's the complement of at least 22 students attending? This is part B. There. We'll call this event capital B for part B. So the event B is at least 22 students attend. Again, don't get tripped up by at least. At least 22 students attend means, well, 22 or more. All right? So 22, 23, 24 students are attending. I like to put that line there and the complements on the other side of the fence. If this is one event, all these simple outcomes, I guess that whole thing there to the left is B. Everything here is B complement. B with that superscript C up top there. Okay, so that's B complement. What's the complement? Let's put it in words. B complement will be in words. So how can I phrase this and have it make sense? I guess that says at most 21 students attend. Right? This would say at most 21 students attend. That's the complements. B, at least 22 students attend is from the line and up. Complement, at most 21 attend is from the line and down. Don't double count anything, right? We won't want a 21 to show up on both sides, so make sure we're crystal clear on that. Probability of B complement. Couple ways to tackle it. If you want, you can add up all the probabilities on this side of the fence. I don't know what's quicker. I mean, that will get us the right answer. To review the rule, it's 1 minus the probability of B. B is everything on this side of the fence. It's 24, 23, or 22 students showing up. So this is 1 minus, let's put some big old brackets, parentheses here. These three added up. 20 and 20 and 10 makes 50, right? But I'm just going to put it here. 10 plus 0.20 plus 0.20. Big old parentheses or brackets. Do this first, right? It's 1 minus, this whole thing is B. This is 1 minus 0.5, 0.50, and the answer is 0.50. All right, dollar minus 50 cents is 50 cents. Okay, so it looks like it's even, Steven, whether we have at least 22 students showing up, or at most 21. It's sort of half and half probabilities. All right. Don't know if that's the end or not. Let's take a peek here. I guess it is. Thanks for watching. See you in class. Study hard.